We have an aircraft heading due east in still air at an airspeed of 600 kilometers per hour. It encounters a wind blowing towards the northeast at 50 kilometers per hour. We want to calculate the aircraft's direction and ground speed. Now, I'm not going to use a vector triangle for this problem, although I could. But let's have a diagram anyway. We know that it's heading this way at 600. It encounters a wind blowing towards the northeast with a magnitude of 50, and this angle of course is 45 degrees. So the resultant velocity is this side here. So if this is the velocity of the aircraft, this is the velocity of the wind, and this is the overall resultant, we can see that V is equal to VA plus VW. So V is going to be, this is going directly east, so that's 600, 0, and the wind is going at 50 cos 45, 50 sine 45. So if I'm in standard mode, I get exact answers. So that's 600 plus 50 cos 45, and that's 600 plus 25 root 2. So that's going to be 600 plus 25 root 2, and sine 45 I know is root 2 over 2, so that's going to be 25 root 2 for this one. So now we could use a right-angled triangle to find what we want to find. So we have a component along here, which is 600 plus 25 root 2, and a component up here which is 25 root 2, and we need this angle here, which I'll call theta. We know that north is up here, and we want this resultant along here. So to find the magnitude of V, we use Pythagoras' theorem. So that's going to be the square root of, let's just pop some brackets in there, and then we need to just pop that in the bracket, and we'll square that. And then we want 25 root 2 squared. So that gives me this. I should go into decimal mode. It's okay, I can just convert. So that's 636.3 kilometers per hour. And then theta is going to be the inverse tangent of 25 root 2 over this, and execute, and once again I should have gone for decimal. And that gives me 3.185. So the bearing is going to be 90, take away that last answer. So we're going to do 90, take away this answer here. So we're going to give that as 0.87 degrees as a 3-figure bearing